Today we are going to start with a new topic, that is the mole concept. See, before starting this topic, I want to convey you something, that many of the students are just scared of this concept, right? So I want that there should be no such kind of fear in your mind. So what I am going to do, I am going to start with the basic thing involved in the mole concept, so that you learn things, so that you should learn things step by step, and there should not be any fear in your mind, right? So just you have to cooperate with me. If you have any questions or anything related to that, you have to ask me accordingly, right? So the first thing what must be striking in your mind is that actually what is mole concept, right? So you should know that mole concept is actually a counting unit. For example, if you just go to market and ask your greengrocer, like if I go to a market and I see a greengrocer selling bananas, suppose, see. So what I ask him that I need a dozen bananas. So what he do actually, he give me 12 bananas, right? Because he know that the dozen means 12, right? So that means dozen is a counting unit. Likewise, if you go to some market and you ask for, you say that I want this thing gross. So that person gave you 144 items, because he knew that gross is a counting unit, and wherever you use gross, it just simplifies that how many items you need. You need 144 items. So likewise, the mole concept is also a counting unit, or you can say mole is a counting unit. So what do you mean by mole now? So obviously mole is a counting unit. Like we have dozen, we have gross, and many more, right? So mole, so now the question is that where this mole is used, right? See, you come across atoms, molecules, ion in chemistry, you know that, right? And they are so small that you cannot, you cannot find their accurate properties, accurate mass, accurate something, but you cannot find the accurate properties of those atoms, molecules, and ions, right? So their mole help us actually. That in case of you can say the atom, suppose I need to find the mass of one atom. Obviously the mass of one atom is like, it is very difficult to know the mass of one atom, because the atom is too small in nature. I cannot isolate it and I cannot know the mass of one atom, right? But we can know the mass of the collective atoms, or collective molecules, or collective ions. So that collection of entities, that means atom, molecule, and ion, corresponds to mole, right? So if somebody asks you what is mole, so you have to answer in this way, that mole is a counting unit, and where it is used in case of counting properties related to atoms, molecules, and ions. That means whose the properties cannot be determined accurately because they are so minute. So we can do it by using the counting unit, that is the mole, right? So how you're going to define that, or what does this mole, like I told you that dozen means 12, right? So that means there will be some specific value which will be related to mole as well, right? So what is that specific value? So mole actually corresponds to Avogadro number. That means Avogadro number gives us certain collective number which signifies that it is a mole. Now what is that number? That is 6.022 into 10 raised to power 23. It is actually the collective 6.022 into 10 raised to power 23, whether atoms or molecules or ions. If somebody asks you, like if I say that 1 mole of atom, if I ask you 1 mole of atom, what do you mean by it? Do you think I mean that that it is one atom? No. If I say 1 mole of atom, so it means it contains how many atoms? It contains 6.022 into 10 raised to power 23 atoms, right? And if I say likewise 1 mole of molecule, then what does it mean? It again doesn't mean that one molecule. It means this much molecules. because we know that mole contains this number, right? So when I say 1 mole of atom, that means how many atoms? This much atoms. If I say 1 mole of molecules, so how many molecules? This much molecules. If I say 1 mole of ions, so how many ions? Obviously this 6.022 into 10 raised to power 23 ions, because mole means 6.022 into 10 raised to power 23, right? Or there is a scientific definition. This is actually the meaningful concept which I have told you, but if somebody asks you for a technical definition of mole, what you are going to answer? So you'll answer in this way, that mole is actually a number which contain as much as particles can be atoms, molecules or ions, which are same as that present in the, or you can say which are same as that of the atoms which are present in 12 grams of C12, that is the the isotope of carbon. So again I am repeating, if somebody asks you to define the mole in a technical language, you need to answer mole is that quantity which contains same number of entities. Entities means they can be atom, can be molecule, can be ions, right? So that means mole is you can say a quantity which contains same number of entities which are present in 12 grams of C12 isotope of carbon. So this is how you will be writing the technical definition for a mole. Otherwise in exams you hardly get a definition for mole. You need to, what you get is the numericals based on the mole concept, but still you need to be familiar with the definition as well. So just write in your copy that what do you mean by mole? Mole is a term that signifies, or you can say mole is a counting unit which contain the same number of entities as present in the 12 grams of C12 isotope of carbon, right? So now you know that what is actually a mole. We know that it is a counting unit, right? Like we use for different items, dozen, gross and like that. We use this mole as a counting unit for atoms, molecules and ions. That means the particles which are very minute in size, whose properties or mass or any other property cannot be you can say determined accurately. Likewise, mole means what? Mole means collection of this much, and this much can be atom, this much can be molecule, or this much can be ion. That depends that what kind of mole you are given. Like if I ask you 1 mole of atom, that means this much atoms. If I give you 1 mole of molecule, that means this much molecule. 1 mole of ion, this much ion. So you have to keep clear in your mind that mole signifies the Avogadro number, that is the 6.022 into 10 raised to power 23, right? So this is actually a mole. Now the second property which you'll encounter in the numerical is that the molar mass. Now what does this term suggest? If I say molar mass, so what idea do you get in mind that what actually it is? Obviously it is a mass of 1 mole, because molar means mole and mass, you know, the quantity of matter contained in the body, right? So if I say molar mass, obviously it is a mass of 1 mole. Now as we know that there is a specific mass for atom, there is a specific mass for molecule, then that means what mass is going to be the mass of mole, like what mass you will be taking as molar mass. So see that if you take atomic mass, suppose I am taking an example to make you understand. Suppose I have oxygen atom. So oxygen atom we know we denoted with O. What is the atomic mass for oxygen? How many times it is heavier than 1/12 of carbon atom? This is what you call as atomic mass, right? So what is the atomic mass for oxygen? It is 16. So that means 16 is a atomic mass of oxygen, right? So is this a mass of one oxygen atom? What do you think? That this 16 is a mass of one oxygen atom, or it is a mass of more than one atom? So you should know that atomic mass actually corresponds to the mass of 1 mole of atom, not of one atom, right? So that means if somebody asks me about the molar mass of oxygen, obviously because we are taking example as of oxygen, right? So if somebody asks me about the molar mass of oxygen, what I am going to say? I am going to say that the molar mass of oxygen is equal to the atomic mass of oxygen, as the atomic mass is not the mass of one atom, actually it is the mass of 1 mole. That means it is a mass of 6.022 into 10 raised to power 23 atoms, right? So that means molar mass of oxygen is equal to the atomic mass of oxygen. So that means molar mass of oxygen is equal to atomic mass we know is 16. So that means molar mass of oxygen is 16, right? So how many atoms you can say possess this 16 mass? If I write the unit along, it becomes gram atomic mass, right? Because we can take atomic mass in different units. Here I am taking it in grams, so it becomes gram atomic mass, right? So if somebody asks me that molar mass of oxygen, okay, it's clear that it is equal to the atomic mass, that means it is 16 grams, right? So is this a mass of one atom? So you are going to say no, it is not a mass of one atom. Actually, it is a mass of 6.022 into 10^23 atoms. These atoms unite to form, or you can say unite to weigh as 16 grams. Right. So similarly, I will be taking an example for a molecule, because when we talk about mole of the molecules, that also corresponds to the molecular mass. See, I am taking an example. Suppose earlier we consider atom, now I am considering a molecule of oxygen. So molecule of oxygen is O2, and we know that the atomic mass of one oxygen is 16. So for a molecule it is 32 grams, right? So that means this is a molecular mass of oxygen molecule, right? So if somebody asks me now molar mass of this O2, so molar mass is just going to be equal to the molecular or molecular formula mass. So that means there is no separate mass for it. Molar mass is actually equal to the molecular mass. So that means in this case, molar mass of O2 is equal to the molecular mass or molecular formula mass, whatever term you can use, because both terms means the same. Whether I say molecular formula mass or I say molecular mass, that means the same thing. So that means it is equal to 32 grams. Again my question, the same question I am going to ask you, that like in this case I told you that I asked you that is 16 gram is a mass of one atom. So you know that it is not a mass of one atom, it is actually a mass of 6.022 into 10^23 atoms. That is, it is a mass of 1 mole. Likewise, I am asking you same question here, that is this 32 gram is a mass of one molecule of O2? So no, it is not a mass of one molecule of O2. Actually, it is a mass of 1 mole of molecules of O2. That means how many? 6.022 into 10^23. So that means this much molecules actually weigh 32 grams. So this is what is the molar mass. I think it's clear. So you have to keep in mind one thing is that what do you mean by atomic mass? Obviously it is a mass of an atom, one atom, right? And if I say molecular mass, so it is a mass of a molecule. That these terms are already clear in your mind because you have studied this concept in 9th as well. Now if somebody asks you that what is the molar mass, so you should know molar mass is actually the mass of 1 mole. When I say atom, so 1 mole of atom. When I say molecule, so 1 mole of molecule. Now what you can say, to what number this molecular molar mass of O atom or molar mass of O2 is equal to? It is equal to the atomic mass or it is equal to the molecular mass. If expressed in grams, we can just convert the term into gram atomic mass and gram molecular mass. Likewise, you will get the question, you need to write the same unit, right? So that is why at this moment sometimes I am using the word gram atomic mass or gram molecular mass, and at some moment I am just saying the atomic or the molecular mass, because they can be in different units, right? So this is what is the molar mass. I think you are clear with the mole. What is it? You are clear with the Avogadro number. You are clear with the molar mass, right? Now the third thing is that what is molar volume, right? So as the name suggests, again it is the volume occupied by 1 mole, obviously, right? And so molar volume is actually the volume occupied by the 1 mole. Now if now what is going to be like, as the mole signifies you can say a proper number, right? It is 6.022 into 10^23. Whether we talk for oxygen, whether we talk for nitrogen, whether we talk for any other element, it is going to remain same. Likewise, the molar mass is just going to remain same. It will depend upon the atomic mass of the atom or it will depend upon the molecular mass of the molecule. Now what about molar volume? So is it going to be same? So you should know that it is again going to be same. And from where we got this idea? Actually the volunteer Avogadro just proved it. Avogadro just made some conclusion in his law, that is the Avogadro law, that will be taking up later, but at this moment I will just explain the law in a short span so that you should have some idea related to this molar volume, right. So Avogadro was the scientist. He just formulated his law, Avogadro law, on the basis of certain experiments, and what he concluded, you know, he said actually equal volume of gases contain equal number of molecules at same condition of temperature and pressure. I repeat, equal volume of gases, that means if the two or more gases have same volume, right, they will contain equal number of molecules. So that means if the volume is going to be same, whether they are nitrogen or oxygen or any other gas, irrespective of the nature, if the volume of those gases are same, so obviously they are going to contain the equal number of molecules. And this whole happens when it happens when the condition of temperature and pressure is constant. That means you need to have constant temperature and constant pressure. So what does Avogadro actually concluded? In a, you can say, in an explanatory way, I am going to tell you. He said that if there is constant temperature and constant pressure, then irrespective of the nature, whether you have N2 gas, whether you have O2 gas, whether you have helium gas, any other gas, any gas, we are not concerned with the nature. So at constant temperature and pressure, equal volume of gases, what matter? The property that matter is the equal volume, right? The volume should be equal and the temperature and pressure condition should be same. So if temperature and pressure conditions are same and the gases have equal volume, so definitely they are going to contain equal number of molecules. That is the 6.022 into 10 to the power 23 or whatever, it just corresponds to the mole. So it was concluded that at STP condition. What is STP? STP is standard condition of temperature and pressure that you can say that you feel at room temperature, right? So this is actually the standard condition of temperature and pressure. So what is like at STP condition, what is the temperature? It is 273 Kelvin, and what is the pressure? It is 1 atmospheric pressure. So this condition you are feeling now also, because these are the normal conditions which exist in the atmosphere, right? So that means at STP condition, equal volume of gas, that means suppose again I am explaining, suppose we have 1 mole of gas. So, right, I am taking an example, I have 1 mole of gas. So how many molecules it will contain? You know that how many molecules it is going to contain, because mole signifies this number. So that means it will contain how many molecules? It will contain this much molecules. So what is the molar volume? Molar volume says that 1 mole of gas which contain this much of molecules at STP condition occupy a fixed volume, and that volume is actually 22.4 liters. So this is actually what is the molar volume, right? So molar volume is actually the volume occupied by 1 mole, and who is the volunteer who just gave the concept, or from where we got an idea? We got an idea from the you can say the law formulated by the Avogadro, Avogadro law. And we just concluded after studying that 1 mole of gas, as we know, contain fixed number of molecules. So that means at STP it is going to have fixed volume, and that volume is something called as the molar volume. And what is the value for that? It is 22.4 liter. So these are the 3 terms actually we are going to use in the numericals based on the mole concept. So now we are in a position to start with the you can say the numerical based questions of the mole concept, right?